This video is going to walk you through a dilution calculation. So what is the purpose of a dilution calculation? Your reaction system is created by mixing known volumes of your reagents, crystal violet, sodium hydroxide, and in some cases potassium nitrate solutions of known stock concentrations. By mixing these solutions together, however, you are changing the concentrations of your reactants from the stock concentrations to new initial reaction system concentrations. A dilution calculation must be performed to determine these new initial reaction system concentrations of your reactants so that the correct rates of reactions and orders of reaction with respect to your reactants can be determined. And we'll go through these calculations in a different presentation. We're just going to focus on dilution calculations with this one. Okay, so what are we going to need to be able to perform a dilution calculation? Let's concentrate just on one of our reagents, crystal violet, in our reaction system. So we want to start off with the molarity of the stock solution of crystal violet that we have. So in this case, in the laboratory, we have crystal violet at a stock concentration of 5 times 10 to the negative 4 molarity. We also want to know the exact volume of that stock concentration solution that we take for this particular reaction system from the burette. So for this example, we'll say that a volume of 2.15 milliliters was taken from the burette for this particular reaction system. So now we want to know what's the total volume of the reaction system. So we've gone from our 2.15 milliliters of stock solution and we're mixing that to make a total volume of reaction system. So we're adding everything together. So here we've got our 2.15 milliliters of crystal violet, and let's say we also took 3.95 milliliters of sodium hydroxide solution and then also 4.05 milliliters of potassium nitrate solution to make a total volume of 10.15 milliliters of solution. The last thing we need is the dilution equation itself. So let's just take a moment to have a look at the dilution equation. Okay, so we start off with the molarity of the stock solution. In our case, we're talking about the crystal violet. Okay, and we also have the volume of that stock solution, of that crystal violet. Okay. If we multiply these values together, we get the total number of moles of crystal violet in that 2.15 milliliter volume. Now, we're changing the volume, so we have a new volume, a total reaction system volume, which we see on the right of our equation. And our target is to get the molarity in this new reaction system. Now, if you look at the equation, you'll see the moles of crystal violet are not going to change, but the molarity is because we are changing the volume. Okay, so let's actually use the equation in a calculation. Remember, we're just focusing on the reagent crystal violet, so we're going from the stock concentration of crystal violet to the initial concentration of crystal violet in our reaction system. So here we've just got our dilution equation and we've just put in all the numbers that we've got from the previous slide. So we've got the stock concentration of crystal violet, the 5 times 10 to the negative 4, multiplied by the volume of that stock concentration solution, 2.15 milliliters. We've also got the total reaction system volume, where we mixed all of our reagents together to form a volume of 10.15 milliliters. So the only value that we don't have is that initial reaction system concentration for the crystal violet. So if we just rearrange the equation, then we can solve for that new molarity. So we're taking our 5 times 10 to the negative 4 molarity times 2.15 milliliters, Divide that by that total volume, the 10.15 milliliters, that's going to give us that initial concentration of crystal violet in the reaction system. So then when we perform the calculation, we get a value of 1.06 times 10 to the negative 4 molarity for the initial concentration of crystal violet in our reaction system.